Hi class, it's me Mr. Morris again, and I'm going to do a little review of how to name compounds. It's called chemical nomenclature. You're going to be working on this assignment over here to refresh yourself on how to write formulas and how to name compounds. I'm going to also make this document available to you. Keep in mind, you don't get to use it on a quiz or test, but I want you to feel free to use it as you're reminding yourself how to name compounds and how to write formulas. We're going to be kind of bouncing back and forth between these documents as we work through this video, and hopefully just kind of reviewing how to use these flowcharts. There are actually two flowcharts. There's this one, and then on the second page you've got a different one, and you just kind of pick which one works better for you. This one goes in a little more detail with ionic compounds, especially talking about if you've got a polyatomic ion in it, but I don't think it really addresses how to name acids, which is something you're probably kind of new to because of COVID last year. We didn't really get into acid naming as much as we normally would, and we didn't touch it at all until the pandemic had already kind of started. So we're going to talk about acids a little bit more, but I'm also going to post a video on how to name acids because I think that the video does a really good job of explaining it in a way that's helpful. All right, let's get started. First thing you need to do is decide if it's ionic, molecular, or covalent is another word for a molecular compound, or if it is if it's an acid, we call it an acidic compound or an acid. All right, here's the trick you got to watch out for. Acids are the easiest to identify because if it starts with hydrogen or H, if we're talking about formulas, if it starts with hydrogen or H, it's probably an acid. The exception is water, H2O. I want you to just always know that. If you see H2O, don't assume it's an acid. We're going to name it water, or you might name it by its covalent name, dihydrogen monoxide, but usually we'll just use the word water for H2O. But anything else that starts with H, you can pretty well assume that it's an acid in this class. All right, covalent compounds are nonmetals only, two nonmetals. Okay, it's just going to be two, that we only deal with binary compounds if you're naming it. Now, there are some exceptions to that, but if you're naming it, it's going to be a binary compound. So that means it'll have two nonmetals like sulfur and oxygen, or chlorine and oxygen or sulfur, something of that sort. It's a combination of two nonmetals. An ionic compound has ions in it. Okay, so usually it's a metal and a nonmetal, or it might be a metal and a polyatomic ion. But I also want you to be able to recognize an ionic compound that starts with NH4. That's ammonium. The ammonium ion is NH4. You want to memorize that. It's the only positive polyatomic ion really talked about last year. So when you see NH4 at the beginning of a compound, and then it's got anything else after it, you can jump to the conclusion that it is an ionic compound. All right, so let's say that we have a list of names like we do right here, and I need to write the formulas. Let's start with the first one. It says lithium chloride. Well, I can look at what lithium is and look at my periodic table. I have one on the wall. You can have one out in front of you. Lithium is a metal. Chloride, well, that sounds like chlorine that we changed the ending to be "ide." Okay, that's Cl. It's a nonmetal. So I have a metal and a nonmetal. That tells me that I've got an ionic compound. So I'm going to jump to this part of my flowchart. And the next thing we need to ask ourselves is if we need a Roman numeral or if we have a Roman numeral. Well, in this case, I've got the name. So I know whether or not I have a Roman numeral. Do I see a Roman numeral written here? The answer is no. So I'm going to have to look at my periodic table to decide what the charge of lithium is. So if I look at lithium, I can see that it's in group 1, and group 1 has a positive 1 charge. So I'm just going to write, and I kind of do my pre-work to the side. I'm going to write lithium with a positive 1 charge. And by the way, if you need to do, I used the wrong shortcut. If you need to make a superscript or a subscript in Google Docs, I'm going to show you how to do that real quick. In Google Docs, if you want to make a superscript or an exponent, that number up at the top, you hit Control period, and then we can say +1. That's what lithium is, right? It's got a +1 charge. I'm going to hit Control period again to bring it back down. All right, lithium has a positive 1 charge. Now I've got to go find chlorine. Well, chlorine's in group 17. It's right next to the noble gases, which tells me it will gain 1 electron to be like a noble gas. That would give it a -1 charge. Since it has a -1 charge, we're going to write Cl and -1. All right, I'm looking at this, and I need to decide, is it neutral or not? If it's already neutral, I don't need any subscripts. In this case, looks like I don't need a subscript, right? So I'm going to go back over here, and I'm going to write LiCl. And that's all I really need to do. All right, now we go to aluminum chloride. Aluminum chloride. Well, first of all, we've got to look at what aluminum is. Find it on the periodic table. It's on the left side of the staircase, so that means it's either a metalloid or a metal. Well, I hope you remember that aluminum is a metal. Okay, so aluminum's a metal, and chloride, again, is a nonmetal. So that tells me I've got an ionic compound. Another trick you might remember, if there are no prefixes in your name, and it doesn't have the word acid in it, it's probably an ionic compound. All right, so looking at aluminum, I'm going to put Al, and we know the charge of aluminum, don't we? Oh. We know the charge of aluminum because it's one of those 3 we memorized the charge of. It's got a +3 charge. So I'm going to put a +3 right here. All right, and then chloride, again, Cl, just like above, it has a -1 charge. Now when you're looking at that, I hope you recognize this is not a neutral compound. Okay, Al has a +3 charge, chlorine has a -1 charge. That doesn't balance. Okay, now I need more negative. I need to multiply it by some number that would make this neutral. So what could I multiply -1 by to balance out the +3? I could have 3 of them. So we're going to write the formula, and remember, you never have charges in your final formula. We write Al, Cl, 3, and this is the first time we've done the subscript, so I'm going to walk you through how to do that. I need to hit Control, comma, and then put a 3, right? And you put Control, comma again if you want to bring it back. So that's AlCl3, aluminum chloride. All right, now we have manganese 2 chloride. Well, now we've got a Roman numeral. That Roman numeral tells me the charge of the polyatomic, or not the polyatomic ion, I'm sorry, of the positive ion. So manganese is the positive ion, and it has a +2 charge. So I can say, over to the side where I do my pre-work, and by the way, if you can do this in your head, you don't always have to do the pre-work, but just to model it for you, manganese has a +2 charge, and chloride, Cl, with a -1 charge. I hit the wrong shortcut out of habit because I'm used to working in Word. Sorry. All right, so it's Control period, and then we do -1. All right, how many chlorides do I need to balance out that +2 charge? Well, I need 2 of them. So we're going to put Mn, Cl, Control, comma, and we put a 2 there. Okay. Now, don't get the idea that you can never have a subscript on the first part of a ionic compound. You absolutely can, and we'll get to some of those. All right, now we get to one that's called nitrous acid. So this is an acid naming thing. There are 3 sentences, and I'm going to have you watch the acid naming rules to learn these. But there are 3 sentences you want to memorize for naming acids. It's my ride has hydraulics, Sprite is delicious, and I ate something icky. So Sprite is delicious. It ends in OUS. So when I see OUS, I'm just going to replace that OUS with ite. Sprite is the way I remember. Ite is tied to OUS. If you have no idea what I'm talking about, you should probably go watch the other video that I put in the link, okay? So I'm going to replace that OUS with ite. Nitrite. Okay, so I'm going to find nitrite on my polyatomic ion list. Nitrite is NO2. And by the way, it has a -1 charge. NO2 has a -1 charge. Okay, that's nitrite. Now, if it's an acid, then it starts with H, but we need to know how many H's it starts with. Well, H has a +1 charge. So how many +1s do I need to cancel out a -1? Well, I only need 1. So all I have to do actually in this case is get rid of the charges because it's already neutral. So nitrous acid, that's what it is. Nitric acid, I ate something icky is how I remember what is tied to the ick. Ate and ick are tied to one another. So nitric acid would be HNO3 because NO3 is nitrate. Okay, down here, dicarbon hexafluoride. Well, that sounds not the same as anything else we've been dealing with. It's got these prefixes at the beginning. That's your hint that we're dealing with a covalent compound or a molecular compound. All right, so dicarbon hexafluoride, that tells me I have 2 carbon because it's dicarbon. And then hexa means 6, fluoride is fluorine. So I'm just going to put C6. Wrong one, C6. And then F6. I did that wrong. It's F6, dicarbon. That would be C2. Hexafluoride is F6. So I'm sorry about that. That is C2F6. All right, let's go down where we're actually going the other way. So if I give you the formula and we want to write the name, okay? Give you the formula, we want to write the name. All right, SRO. So I have Sr, that's strontium, and then I have O, that's oxygen, okay? Strontium's a metal, oxygen's a nonmetal. That tells me it's an ionic compound, so I have to look over here. I need to know if the metal forms one type of ion only or if it can form multiple types of ion. Well, if you were looking at the periodic table, you'd see that strontium is in group 2, and we know group 2, we know what charge it has. It has a +2 charge. I don't need a Roman numeral. Okay, so my name is just going to be the name of the cation and the name of the anion. The anion, since it's just one nonmetal, I'm just going to take the name, the root name, and replace the ending with "ide." So this becomes strontium. And instead of writing oxygen, I'm going to replace the end of it with "ide," oxide. Strontium oxide. All right. Then I come down here, I've got SNO. Well, SN is a different element, that's tin. If I look on the periodic table, SN is over there in the part of the periodic table I don't know the charge for. Okay, since I don't know for sure what its charge is, I'm going to have to go down this part of the flow chart. Okay, I'm going to have to find a Roman numeral. Okay, it's still just going to be tin, not Tim, tin, but I'm going to need to write a Roman numeral. Let's click over here and scroll down, okay? And then I need to have the base name of oxygen replaced with the ending "ide." The exception to that, of course, is if we have a polyatomic ion. We'll talk about those two. Okay, tin something oxide. I don't know what that Roman numeral is, though. Well, this is where you got to do a little bit of work, a little bit of math. Not a ton, but a little bit. Okay. Sn, we don't know its charge. Okay, so I want to figure out what its charge is, but I don't actually know what it is. Okay. And then I have oxide O. We know its charge. It has a -2 charge. Now, I want to know the charge of the other side. So if I only have one oxygen, one oxide actually, and that oxide has a -2 charge, 1 times -2 is -2, the other side has to add up, it has to combine to be +2. Okay, so I had a -2 over here, I have a +2 over here. Since there's only one Sn that I have to work with, all of that +2 charge has to be on that. So I know now that my charge is +2 because it has to be in order to balance this out. The Roman numeral tells us the charge, so we write the Roman numeral 2. And that's how you find the Roman numeral. All right, here's another one, CO. Well, I've got to decide, is this what type of compound is this? Well, I've got 2 nonmetals. Carbon's a nonmetal, oxygen's a nonmetal. So I need to follow my naming rules for covalent compounds. That's the one in the middle. All right. Molecular compounds, we're going to do prefix, name of the first element, prefix, the base name of the second element, ending in "ide," just like we've been doing with ionic compounds. So CO is going to be carbon. Now, wait a second, you said prefix. Why is there no prefix on this? The one exception to the prefixes is we do not use mono on the first element. If it's more than 1, if it's 2 or 3 or any number, we still use a prefix for the first element. But if there's only 1, you do not use a prefix for the first element. Okay? And then the second name is going to be some prefix, and then we're going to put oxide. Well, there's only one of those too. That's right, but you still use the prefix, monoxide. Okay? We use a prefix on the second name even if it's mono, but on the first name you never use mono. And that's kind of the trickiest part of covalent naming. I think most of you guys are pretty good at it, but you got to remember that part. All right, and then we get to an acid. So we have hydrogen at the beginning. That tells me it's an acid. All right. It is not a binary acid. It's got to be an oxyacid because I've got multiple elements. I've got 3 different elements in this. So I've got to figure out what is this part called, CO3. What is CO3? Look at a polyatomic ion chart or have it memorized. You eventually need to memorize it. And you'd find out that CO3 is called carbonate. So I'm going to do that as kind of my pre-work over here. Carbonate. Okay? So that sentence that we remembered, ate, changes into ick because I ate something icky. Okay? So we're going to use the base name of this, which is carbon, and we're going to replace the ate with ick. So this is carbonic acid. That's carbonic acid. I'm going to skip a few of these. go find one. It's maybe a little more tricky. How about this one? HBr. HBr. Well, that's a binary acid. So I'm going to put hydro at the beginning because it's only 2 elements. Now, if I was naming this as an ionic compound, I'd call it hydrogen bromide. So the ending is "ide." In the other sentence, my ride has hydraulics. So we replace the "ide" at the end with "ic," and we always put hydro at the beginning if it's a binary acid, or if the second ion would have actually been an "ide" ion. So this is hydro, and then brome, because it's bromine, ic, acid, hydrobromic acid. Okay. I'm gonna, like I said, I'm gonna post the Tyler DeWitt video. He does a really good job explaining all of the acids. But I hope that this was a good review of the 3 types of compounds that we name in chemistry.